Our topic now is wavelength division multiplexed networks. You already have studied what is WDM in the previous modules, but then in our present module we will be studying it again. So wavelength division multiplexed network in short is called as WDM. This can be classified either as a broadcast and select type, or it can be called as a wavelength routing network. So basically the wavelength division multiplexed network can fall into two categories. So it can be considered for the broadcast and select network, or you can consider it for the wavelength routing network. So we will study more about this. So we can consider this particular picture which is being displayed here on the screen. So the optical transmission is broadcasting of the other nodes using the fixed transmitters and a tunable receiver at the destination node, which will extract the desired signal from the entire group of wavelength multiplexed transmitted signals. So I'll explain more about this. So let me now consider there are certain signals. These signals basically are represented by the wavelengths that may be lambda 1 to lambda n, which are present here. These are the fixed transmitters. Tx will stand for the transmitter. This has got certain wavelength lambda 1, lambda 2, so on up to lambda n. It should be noted that all of the transmissions are broadcasted to all network nodes, and hence most of the transmitted power is depleted on the receivers which do not use it. So the next point is, consequently, as the number of nodes will increase, each station receives a small fraction of overall transmitted power. Every station that we consider here will be considering a small power or a small fraction of overall transmitted power. Alternatively, when we consider the wavelength routing network, it can be used to avoid the wastage of the transmitted power, where each node within the network is provided with the restricted number of connections to the receivers. So in the wavelength routing, instead of distributing the message over the entire network, the signal is routed to a specific destination through either a single node or the multiple nodes. Now let me explain you all the same thing. See, in this, I hope you all have understood, there are fixed number of transmitters and there are tunable receivers. What is the job basically? The job here is basically to see to it that the optical transmission is being done over the fixed transmitters, and we are using a tunable receiver at the destination which will extract the desired signal from the entire group. So entire group is being sent, but then out of whichever is required is collected or which is received by using the tunable receiver out of the multiple wavelength multiplexed transmitted signals which fall between lambda 1 to lambda n. So the next one is now the wavelength routing. So I'll explain to you all about this. This is a very interesting concept. So here the wavelength routing is basically a physical bidirectional interconnections. Here in the first picture you can see that there are 5 nodes A, B, C, D and E. So it is about the bidirectional interconnection. See, this uses 3 wavelengths, which is lambda 1, lambda 2 and lambda 3. So we can see that in this second picture, wherein we have used 3 different kinds of wavelengths. First one is lambda 1, second is lambda 2 and third is lambda 3. Any network node can transmit or receive a signal from another node within the network. So everything has to happen between this network or between this network assigned only. So here we will consider this concept by considering the 5 nodes, that is A, B, C, D and E, and the wavelengths assigned are lambda 1, lambda 2 and lambda 3. So this has to transmit and receive the signal from each node by conducting this process within the network. Now, this strategy of wavelength implementation or path selection happens in this second picture. Here you can see that certain signals are being transmitted from one node to the other. This is known as the wavelength routing and wavelength assignment, which is called as RWA. Routing and wavelength assignment happens in the second picture. We call it as RWA. So here what happens is basically we do the routing and we assign the wavelength. That is why we call it routing and wavelength assignment. So let me give you an example. Basically you can consider a node A that can transmit to node B using wavelength lambda 1. So here A to B, the data is transmitted using the wavelength lambda 1. So next is it can simultaneously receive from node B using lambda 2. So we can even consider, see here what we can see is this dotted line is representing the transmission of data from node B to node A using some other wavelength which is represented by the term lambda 2. So here the next thing is we can consider it simultaneously from node B to node A by using the wavelength lambda 2 only when the signal is routed through node E. So how is it being transmitted? So from A to B it is being sent directly, that is the lambda 1, but from B to A when you are transmitting it is happening through another node which is called as lambda E. So from the signal which is having the wavelength lambda 2 is first being transmitted to node E, and then from E it is being sent to node A. So now this is having an indirect path. So in the previous case it was the direct path. To simplify such routing and wavelength assignments, a virtual topology is generally created which uses the enabled wavelength paths. The virtual topology is being shown in the picture 3, what you can see here, where only wavelength signals identify the possible interconnections between the nodes given by RWA. So it will only consider the signals which are considered using the RWA, that is routing and wavelength assignment, and whichever happens with the help of RWA are being observed here. So there is no dotted line which is shown, directly you can see the thicker lines only. So here there exists no physical connection between node C and E. Is there any direct physical connection? No. So there is no physical connection between C and E, but both the nodes can communicate via a virtual connection setup by using lambda 1 and lambda 3. So in the previous case when you were seeing there was no physical connection between nodes C and E, but then still they can communicate via the virtual connection which is set up between them by using the wavelengths lambda 1 and lambda 3. So here both the broadcast and select as well as the wavelength routing network can be further classified into single hop or the multi hop. So if it is a single hop, then it will allow the direct communication between the two nodes and the data remains entirely in the optical domain. It will not use any optoelectrical conversions until it reaches the destination. But if it is a multiple hop, a transmission may take place through the intermediate nodes before reaching the destination. That is, at each intermediate node, the data can be switched electronically to the next possible node and then it is retransmitted as an optical signal. But then this process is inefficient and it is necessary if there is no common wavelength path between the two nodes to establish the direct connection. So basically wavelength routing is about the techniques that happen over the first is the physical connection, second is the wavelength assignments, that is nothing but RWA, that is routing and wavelength assignments, and the next one is virtual topology. So the virtual topology is all about where the wavelength signals identify the possible interconnections between the nodes which is given by RWA itself. So I hope the topic is clear to you all.